Hello everyone, I'm Martin Berg. I'm a faculty member in the Mechanical Engineering Department at the University of Washington. And in this video, I will introduce you to LabVIEW. Well, first of all, LabVIEW is a software package. It was developed by National Instruments Corporation tens of years ago and made a name for itself very early on in the area of virtual instruments. So just what is a virtual instrument anyway? Well, many of you, I expect, have had occasion to interact with things like oscilloscopes and function generators in laboratories here on campus. Those are physical instruments. A virtual oscilloscope, by contrast, would run on the desktop of your laptop. It would have displays and buttons and dials that you could interact with using your computer mouse, typically. You could also have a virtual signal generator running on the same desktop. It would have a different set of displays, a different set of buttons and dials. Those are examples of virtual instruments. This is a particular example of a physical instrument, or rather a photograph of one. It's a kitchen timer, of the sort your grandmother might have had in her kitchen. In our video today, we're going to develop a virtual kitchen timer using LabVIEW. Before moving on to bringing up a LabVIEW window and starting that process, I want to use this image to introduce some basic LabVIEW terminology. For starters, every program that you will likely write in LabVIEW will have a file type .vi, the VI standing for virtual instrument. And every virtual instrument in LabVIEW has fundamentally two parts. One is the front panel, the other is the block diagram. The front panel in a LabVIEW virtual instrument is the interface with which your user interacts with your device. For our kitchen timer example, the front panel has a control. That's the dial that you reach up and grab and rotate to say 10 minutes for your pizza to bake. That's the control aspect of our kitchen timer. The indicator aspect is after you let the dial go at 10 minutes, the timer slowly ticks down and you can always look at it and see how many more minutes before your pizza is done. So every front panel in LabVIEW has two and only two things. One is controls and indicators. What about the block diagram? Well, the block diagram is the space in LabVIEW where you create the functionality for the inner workings of your device. So in our kitchen timer example, the block diagram has the inner workings of the timer. If you turned it around and pulled the back off, you would see inside there are going to be some, well, springs and maybe some little gears, and there's certainly going to be a little bell and a hammer. Those inner workings of the physical kitchen timer are what you would program on a block diagram if you were building a virtual kitchen timer. All right, so let's get started on building this virtual kitchen timer with LabVIEW. I'm going to start up LabVIEW by clicking on the icon in a taskbar in my case. You should see a window rather like this, a getting started with LabVIEW window. I'm going to, under the file menu, I'm going to select new VI. And I get two windows. The first one is labeled front panel. The second one is labeled block diagram. As we mentioned earlier, every virtual instrument in LabVIEW has a front panel and a block diagram. So let's see here. I'm going to start on the front panel. And on the front panel, I want to add something that looks like a dial, the dial on our kitchen timer. I need to go find it, and I need to be looking in these controls palette, since that's where controls and indicators reside. So I don't see it at the moment, but if I, let's see, go to the front panel, right click, there appears the controls panel. If I click on the little push pin there, it sticks. So I'm looking for something like a dial, and here you're seeing that the controls palette, there are many subpalettes: modern, silver, system, classic, add-ons, user controls, etc. Maybe I'll mention that the modern, silver, system, and classic subpalettes, my understanding is that those names refer to basically the styles. If you want to add a dial to your front panel, you can pick one from the modern subpalette, or you can pick one from the classic subpalette. and the modern dial you pick will have a slightly more modern appearance, as I understand it, than something from the classic subpalette. In any case, I'm looking for a dial control for starters. I could go searching for it, but instead I'm going to press the search button, enter the term dial, and see what we get. We see a classic dial, we see a dial numeric controls, and we see a dial numeric, and we see a dial under the silver palette apparently. You could check these out, but I happen to know that this dial numeric is actually the one we're looking for, so I'm just going to click on that. I guess double click. And so it's gone to the palette where it's located. Apparently this dial control I'm looking for is under the modern subpalette, under numeric subpalette under that, and here it is. So I'm going to grab it with my mouse, pull it over, and place it on my front panel. Okay, so let's see. Here we have our dial control, and it has a title. The title is dial. Every control and indicator on the front panel will have a name. This one is by default named dial. I do have the option of either displaying or not displaying the name. Let's see, to bring up some of those options, I need some tools. I don't see anywhere in my desktop the LabVIEW Tools palette, and so I happen to know that if I go to the View menu on the front panel and single click, I see View Controls palette. I'm going to select that, and where is my Controls palette? Let me try that again. View, Tools palette is what I was looking for. Here it is. So here's my Tools palette. The Tools palette has got things like, well, I call this the Operate tool. There's the Arrow tool. There's this Text Entry tool. There's a Wiring tool. And there's some other tools here we'll talk about on other occasions. But in any case, I want to use this Arrow tool. It looks like it's referred to as the Position Size Select tool. I want to select this label or title for my dial indicator. And now I've got it selected. I want the Text Entry tool. That's this guy. I want to go over here and double click on it. You'll see it turns black. And I want to title this front panel control. I want to put a title on it, time, space, and seconds. So that's my title for my front panel control. I use the Arrow tool and kind of move this out of the way a little bit. Now the next thing I want to do is make my dial a little bit bigger, so I'm going to just grab one of these handles and enlarge it a bit. Okay, so far so good. Well, the first thing I notice is this dial, it's displaying values that are not strictly integers, so it's some sort of a floating point representation, and I want a dial that displays integer values. So let's see, I'm going to use the Arrow tool, right click on this control, hit Properties, and let's see, Appearance. If I go to the Data Type pane, I can see that, okay, the current rendition of my front panel dial is using a double precision value. I want to designate my control to generate an integer value, so I'm going to, let's see, right click on this guy, or no, just click on it, and here it gives me the representation options. Right now it's a double. I want an integer value, and we see I8, I16, I32, and I64. The numbers after the I is corresponding to the number of bits being used to store the integer. I'm interested in integers to go up to 60. I could use I8 if I wanted to. The sort of standard with LabVIEW is I16, so I'm going to select that guy. And now you see that now my front panel control is displaying strictly integer values. If I want to go from 0 to 60 instead of 0 to 10, I can use the, let's see, Text Entry tool. Oops, I need to OK that. If I go to the Text Entry tool like so, I can come over here and change that 10 to 60 like so. And now I get a front panel control that's showing the time in seconds from 0 to 60. And that's basically what I want. So that's the front panel control. I've discussed how to find front panel controls and indicators. We've discussed the tools palette. Another window that you're likely to want to have open on your desktop when you're doing LabVIEW programming is the context help window. And so under help, I'm going to right click, or I guess left click, and say show context help. Here's the context help window, and you'll notice that if I use the arrow tool and click on my front panel control, let's see, if I click on my front panel control, what's it giving me? Well, it's not giving me anything, I guess, all that useful. But in general, when you have the context help window open, when you click on something on a front panel or control, it'll give you some at least summary information about what the object is and how to use it. And it'll also, typically, there'll be a detailed help link that you can go to get more information. In any case, the context help window is something you probably want to have on your desktop mostly all the time you're programming in LabVIEW. All right, so that we started with a little bit with the front panel. I want to go to the block diagram. That's back here. You can see on the block diagram that indeed our front panel control, named time in seconds, it has a presence on the block diagram, and this is it. Maybe I'll also comment that LabVIEW, as you're about to see, if you weren't aware of this, LabVIEW is strictly a graphical programming language. There's no lines of code to write, although you can actually write even M files and lines of code and enclose them in a VI. But for the most part, LabVIEW is strictly a graphical programming language. Here we have a icon that represents our front panel control. It's shown in blue. LabVIEW is a very visual language. Blue is generally the color of an integer value. Floats, I believe, are an orange color. Booleans, true-false values, are green. In any case, this use of color in LabVIEW you'll find is helpful, very helpful. So the next thing I want to tackle in our kitchen timer VI is the timing. That is the countdown in seconds. And like most any programming language, there's many different ways one could do that. The approach that I'm going to take is to use a while loop in LabVIEW. And so let's see here. I don't see my functions palette, so I'm going to right click on the block diagram, hit the push pin, and I just happen to know that, let's see, the while loop is a structure, and it resides under the programming subpalette of the functions palette. So let's see, I want to look at these structure options, and let's see, I see a for loop, a while loop, a time structure, etc. I want to choose a while loop, so I'm going to click on that guy, drag it over to my block diagram, right click, and then drag to form my while loop. I'll get my functions palette out of the way. So I've created a while loop on the block diagram in my LabVIEW VI. And now you can clearly see that if I look at the context help window, it's giving me some information about this while loop. It's hard to see, but I'll make sure this is selected here. So in any case, when I select the while loop on the block diagram, the context help window gives me some useful information. For this while loop, which you'll be using probably frequently in this course, it would be a real good idea to click on the detailed help and spend a little time reading about the real workings of a while loop and how they can be used. We'll exercise some of these features here in a minute, but I encourage you to do this on your own time. For now, I'll close this detailed help window, and let's see here. So I've got my while loop. What else am I going to need? I need this while loop to execute once a second, And so I need somehow to implement this 1 second delay, if you will, on each execution of the while loop. Again, there are multiple ways to do that, but let's see, if I close the structures subpalette and under the programming menu, if I look for timing, I will see a wait until next milliseconds multiple. And if you're looking at the context help menu, you can see that it's telling me what I'm pointing at. There's a time delay. We could also use a 1 second time delay. The one I'm most used to working with is the wait until next milliseconds multiple timing element. So I'm going to select this guy and pull it to my while loop and drop it. If you now click on it and look at the context help window, you can see it has an input showing in blue, meaning it's an integer value, and the input is a millisecond multiple, and the little description here says wait until the value of the millisecond timer becomes a multiple of the specified millisecond multiple. We want our wait until next milliseconds multiple VI to wait 1 second, so we want to enter a value of 1000. And again, there are multiple ways to do that with LabVIEW. We could certainly place a constant integer value and wire that to the input to this this little VI, but actually the more efficient way that I want to point out to you is, let me see here, if I guess maybe I need the wiring tool to do this, so let me make sure I've selected the wiring tool. Here's the tools palette. Select the wiring tool, come over here to this wait little VI, and if I move the wiring tool over it, you'll see that the input node or the input terminal shows up, and if I point at that input terminal and right click, you'll see I get some options. The options I happen to know that I want is under create. If I say create constant, you'll see that I have created an input to this little wait until next milliseconds multiple VI, and the input value is an integer. It's hard to see perhaps, but it has a blue border. It's got a black inside indicating that LabVIEW is giving me an opportunity to enter a value. If I type 1000, I basically got exactly what I need to control the timing. That is, with this little wait logic in my while loop, the while loop will execute one time every 1000 milliseconds or 1 time per second. So I want to use this while loop to count down from the initial value that's read from the front panel control to 0, and later on I'm going to add the bell functionality, etc. But somehow I need to tell LabVIEW that I want this front panel control value to be read, and so I'm going to bring up the wiring tool, and if you look closely at this little node, this is called on the block diagram, it has on the right side, it has a right pointing arrow that indicates that it has an output value. Well, if I use the wiring tool, I can wire that to my while loop, and I get this little blue box, which if you look at the detailed help for a while loop, identifies the connection here as being a tunnel. The wire goes into the while loop through a tunnel. So let's see here. That's actually not what I want. What I want is, yes, I want this front panel control to be read to get the initial time for the count that's supposed to take place. But each time the while loop is executed, I want the current count that's initially obtained from this front panel control to be decremented by 1. And so, in fact, to do that, I want to, and again, you'd have to look at the detailed help for a while loop to see this, but I'm going to use the wiring tool, right-click on this tunnel, and select to replace it with a shift register. And so you'll see the icon is different. It's got this a triangle pointed down now instead of just a blue box. And simultaneously, I created on the right side of my while loop, I created a corresponding little triangle box where here the triangle is pointed up. Essentially, the shift register, what the shift register does is at the end of each execution of the while loop, the value that's wired to the shift register on the right side, the outgoing side, if you will, gets fed back to the shift register on the left or incoming side of the while loop. It turns out that's what I want, but what I'm still missing is the decrement of the current time in seconds that's supposed to appear on the front panel as it counts down. So let me see here. I happen to know that, let's see, under programming, numeric, I think it is, and you're going to have to spend some time using the search button and exploring some of these palettes, but under programming numeric in the functions palette, I'm expecting to see a decrement operator. Here it is. So I'm going to pull this decrement operator up here, and it's going to decrement the input value by 1 and produce an output value. And if you look at the context help menu, that's exactly what it says about this little VI. So I'm going to grab the wiring tool from the tools palette, wire this incoming shift register to this decrement operation. And if you looked real closely, you might have noticed that the decrement operator just a second ago had its output, input and output terminals were orange, which would indicate a float, but it automatically recognized that I wired to it an integer, so it actually changed its representation to an integer value. So I'm going to grab the output terminal of this decrement node and pull it over to this right shift register. And so the functionality I've got now is when LabVIEW starts up, it will read the value from the front panel control, which the operator will have set with his mouse. That value will be passed to this input shift operator for this while loop. It'll instantly be decremented, and so, for example, if the initial value from the front panel is 10, when we start it up, this wire will contain 10. That will come into the while loop through the shift register. 10 will be decremented to 9. But then the next thing that's got to happen is, well, meanwhile, LabVIEW is waiting 1,000 milliseconds or 1 second. And so it's not until the 1,000 milliseconds is counted down that this decremented value is going to be passed back to the input shift register here on the left. So I'm getting there. Let's see. The next thing I need to do is to worry a little bit about the stop condition for this while loop. And the stop condition, again, if you look at the detailed help for a while loop, you'll see that this little like a reddish stop sign is related to the stop condition from my while loop. And I believe if I right-click on it, you'll see there are several options. It currently is set to stop if true, continue if true, and there are some other options. Let's see. I want my while loop to continue if the input value to this stop condition is true. So I'm going to switch that to continue if true. And you can see that the color changes slightly. How am I going to, and this, again, the detailed help about a while loop will tell you that, hey, this guy is expecting an input value, and you can see that if you have a high resolution screen, at least there is a little input node showing up on this little icon. The way I want to use that is I want to wire this incoming count of seconds. I want to wire that to the input to this VI, and oops, oh, that won't work because I just tried to wire an integer value to the input terminal of a node that expects a Boolean. So LabVIEW is telling me here that, hey, I can't do that. So I'm going to select that wire and hit just the delete key. I better do that twice, it looks like. So what I wanted to do instead was I need to add a comparison VI, something that's going to check to see whether this wire here in the block diagram is still positive as it counts down. And gosh, I've done some searching before. It turns out it's not in the numeric subpalette, it's in the comparison subpalette. So here are these comparison functions, and the one it turns out that I have used in the past for this is the strictly greater than 0. So I'm going to pull this guy and pull it over to my block diagram like so. And so then I'm going to wire. So I need the wiring tool back. I want to wire from here to this greater than or equal to 0 comparison VI. And so again, if you look at the context help window pointing at this node, you'll see that it takes an input value here indicated by X, and it generates a Boolean that is a true-false value according to whether X is greater than 0 or not. And so that's the Boolean that I want to run to this stop condition node in my block diagram. So I'm going to select the wiring tool, wire this guy from here to there. And now you can see that indeed LabVIEW did not balk at my wiring. I have a little node that's expecting a Boolean value that the while loop will use to determine whether or not it's done, and I've wired a Boolean value to it. So let's see, what else can I tell you about this while loop? This guy down here, actually, this is the loop iteration count. You'll see it has a little I in a box, and the box is blue. This, again, the detailed help for a while loop will tell you that if you need inside your while loop to know the iteration count, you can get an output from this little node, and that's the way you can obtain the iteration count from within your while loop. So let's see here. I think we're about ready to run this VI for the first time. So let's go back to the front panel, and here it is. Actually, the one thing I should do before I run it is I should save it. So I'm going to pull this up here a little bit. You'll see on the front panel, currently I have a front panel, and the VI is currently called Untitled 1. The star after front panel indicates that there's been some changes made and I haven't saved it. So I'm just on the File menu, I'm going to select Save. Oh, and it asked me where do I want to put it. Well, let's see, I'm just going to put it under the desktop, and it wants me to give it a name rather than Untitled 1. I'm going to enter a name, Kitchen Timer. Kitchen Tea, just for short. Kitchen Tea. All right, so that's going to be on my desktop. On the toolbar here, we see several icons. The one on the left, the right-facing arrow, is the Run icon. If you noticed that earlier, until I had all my wires connected on my block diagram, that had a slightly different appearance. The fact that it's a healthy-looking arrow at this point is telling me that my VI, as far as LabVIEW is thinking at this point, is ready to run. So I'm going to select the Operate or Hand tool and say choose a number of seconds for my timer to count down for, and I'm going to choose 10, and I'm going to hit the run button. And I want to warn you, you're not going to see very much. Well, let's just go ahead and do it. I'll hit the run button. And you'll see the run button has sort of got a different appearance, like something that's actually moving perhaps. But I'm not seeing the pointer on my front panel count down. I promise you it counted down for 10 seconds, and now it's done, and I have the original run button appearance again. But clearly, we've got a long ways to go yet before we have this front panel control that emulates this physical kitchen timer that they were out to produce. So next, I want to go back to this front panel and make it emulate better the behavior of the physical kitchen timer when our VI runs. So I've got the arrow tool selected. I'm going to enlarge this a little bit. And first I just want to illustrate something on this front panel. We discussed how a front panel can have controls and it can have indicators, but that's it. So far we've got this dial control on the front panel. If I select the direct selection tool here, the selection tool, click on this guy and hold down the control key on my keyboard, and let's see, I'll drag a copy over to the right. Now I've got two front panel dial controls on the front panel, and you see that LabVIEW has assigned a unique name to the second one. But I want next to use this same selection tool. I want to right click on this front panel control and select Change to Indicator. And that's a kind of a surprising thing about items on the front panel in LabVIEW. If you have a front panel control, you can switch it to a front panel indicator and vice versa. So now we have a front panel dial control, a front panel indicator, and I want to go back to the block diagram for a minute. So here LabVIEW dropped in this icon representing our front panel indicator right here, and I can see it's an indicator because if you look closely, there's a little triangle on the left edge, and the left edge is the input edge on a block diagram icon, whereas here the front panel control icon, the arrow, you can see the little triangles on the right. In any case, this guy is ready. It's an indicator. It's ready to accept a signal that it's going to display on the front panel. So I'm going to oblige by using the wiring tool, and I'm going to wire this guy to this signal. Oops, there we go. There we go. So what's going to happen is now we should see our front panel indicator count down the countdown of the seconds should appear on this front panel indicator. I'll go back to the front panel and use the operate tool. I'm going to select, say, 15 seconds. I'm going to hit the run button. And indeed, now we're seeing here on the right, this front panel indicator is counting down. And between the two of these, we have the kind of front panel behavior that we want to see for our virtual kitchen timer. And wouldn't it be nice if we can ascribe to this front panel control this sort of indicator behavior we're getting here on this dial on the right? And it turns out that with LabVIEW it is possible to do that, and that's a bit of an advanced topic, but I'm going to show you how that can be done next. So I'm going to choose the selection tool. I'm going to click this guy, and then I'm going to hit the delete key to delete it. I go back to the block diagram, and now I've got some broken arrows because I've deleted my front panel indicator that was here just a minute ago. Rather than selecting those two parts of that wire and deleting them one at a time, I'm going to hit Control B, which will delete all broken arrows in my block diagram. And so next step is to ascribe this indicator behavior to this front panel control. To do that, I have the selection tool active. I'm going to right-click on this node and select Create Local Variable. And now you see the mouse is waiting, or LabVIEW is waiting for me to position this local variable that I've just created. I'm going to position it right here inside my block diagram. And if you'll right-click it, you'll see I have a Change to Read option. Right now, this local variable is set to read a value. Its input icon on the left is active, the little triangle there. And so indeed, if I use the wiring tool, I can wire this signal to this local variable like so. And now if I go back to the front panel, use the Operate tool to, say, pick 17 seconds, and then run the VI, we're seeing that, aha, now we have our front panel control that has some of the characteristics of an indicator. That is, it's indicating the time left on our timer, and that is exactly the behavior we'd like for our front panel control when it comes to emulating this physical kitchen timer. And in fact, we're close now. Really, the one thing we're missing is we'd like our kitchen timer to beep or ring when the counter on this front panel control counts down to 0. So we need to add a functionality to our kitchen timer VI that'll allow it to play a sound. You might think there would be a LabVIEW indicator in the controls palette that would do the job, but in fact I tried that. I did a search for the word sound in the controls palette and I got no hits. So I'm going to go back to the block diagram by clicking on it, and then go over to the functions palette and type in the word sound, and you can see we get many hits. You could browse through some of these with a context help window, but in fact I've done that, and I happen to know that the play sound file VI will do the job, and you can see the context help window is giving me some basic information about how this VI works in its window. But I'll double click on this play sound file VI, and here it is in the functions palette. I'm going to want to, so I'll drag it over to the block diagram, put it here on the right, and in fact I am going to enlarge this a little bit so we get a little more space to work with. Here's my play sound file VI added to my block diagram, and now I want to look at the context help menu to learn how to use it. I got too many windows in the way. So I've got this play sound file VI highlighted. This is telling me how to use it. It's got it requires a device ID, a path, and timeout, and there's a timeout input. If we check on the detail help, we get much more information about how this thing works. Let's see here. Timeout in seconds, for example, specifies the time in seconds that the VI waits for the sound operation to complete. The default is 0. This VI returns an arrow if the time elapses, unless timeout seconds is 0. If you set timeout seconds to 0, this VI returns immediately while the sound file continues to play. Finally, if you set timeout seconds to -1, this VI waits until the sound file finishes. So that sounds like what we want. Sounds like we need this input timeout in seconds to be -1, or certainly that would do the job for us. We also need the path because this VI plays a sound file. And so we need to find a sound file online somewhere. It turns out I've already done that, and I put it on the desktop, and that's the one we're going to use. The other input we need to know about is the device ID. The device ID is the output. I'm looking at the help page here. Device ID is the input or output device you access for a sound operation. And this is something that you pretty much have to do by trial and error on your machine. It turns out for my Mac, the standard output speaker set is the device ID is 0. So let's go back to the block diagram, and we need to add this, well, let's see. We can use the wiring tool and right-click on this timeout in seconds and select Create Constant. And the default apparently is 0, but we want this VI to play the sound until the sound file is done. So I'm going to type in a -1 because that was the option for that. Let's see. On the top left input, that's got to be the device ID. I'm going to right click on that node and enter create another constant. And for my machine, that turns out to be 0, so that's what I need. Finally, at the path input to this play sound file VI, I need the path to a sound file. And I happen to have found and saved a sound file earlier. Let me locate it. Here it is underneath everything. I'm going to drag that up on top. The title is rooster.wave, so you can tell it's not going to be a bell or a ding. It's going to be a rooster crowing. If I right-click that guy and select Properties, I can see, let's see, the path name is going to be C:\users\desktop. I'll do a Control-C for copy. Use the wiring tool, right-click that path input, right-click it, and type or enter create constant, and Control-V will paste in. I've got the path there. I need the complete file name after that, and that's rooster.wave. Control-C, back here, text entry tool. I believe I need a backslash, Control-V. Now we've got a complete path name to our play sound file VI to play this particular sound file. All looks well. I see the arrow tool looks healthy, so we can run this guy. Now to do that, we could go back to the front panel, but in fact we can run this VI using the run button right here on the block diagram. Before I run it, I want you to think about what's going to happen when I press the run button. Honestly, the first time I did this myself, what I expected was that, okay, I could set the timer to 15 seconds on the front panel, come back here to the block diagram and hit the run button, and we ought to start here on the left, and we would read the 15 seconds from the front panel. The while loop would start. There would be the countdown to 0 seconds, and the while loop would finish, and we would hear the rooster crow. Well, in fact, that isn't what happens, and it was a good lesson for me, and maybe it'll be a good lesson for you. Maybe let me just go back and we'll check, and we'll see what happens. But ask yourself what should happen here. See how up to speed on LabVIEW you are already. So I want the Operate tool. I'm going to set the initial time to, say, 10 seconds. Go up and hit the Run button. So that wasn't what we expected from our kitchen timer. And why is that? Well, it's a good lesson in this data flow paradigm that LabVIEW is using here. When we start this, when we run this VI, hit the run button, LabVIEW looks at this block diagram and says, what can I do first? And my thinking, my incorrect thinking was, well, it's going to start in the left and go left to right. Well, that isn't what LabVIEW is thinking at all. It looks at this block diagram and asks itself, what several things perhaps can I do right off the bat? And the answer is, well, it can read the initial time from the front panel control, but it can also play this sound file VI. And that's what it did. So somehow we have to modify our block diagram here so that this rooster sound doesn't get played until this count within this while loop is counted down to 0. Again, there are multiple ways that one could accomplish that within LabVIEW. The way I'm going to show you is using a case structure, adding a case structure to the inside of the while loop. So I'm going to go over here to the functions palette. We don't want to look at, we want to look under programming, but not graphics and sound. It turns out the case structure is under the structures palette. You could also do a search and find it that way. Okay, here's our case structure. That, it turns out, is what I want to use. So I'm going to click and drag and put in a case structure right here. Is that big enough? No, I think I need to enlarge my while loop and enlarge my case structure a little bit. So my case structure, it has a true case and a false case. Let's see, the action that I'm looking for is, let's see, when this Boolean turns false, meaning we've counted down to 0, I want to play the sound file, and so I want to go to the false case, use the pointer select tool, drag my play sound file VI and its accoutrements into the false case. Let's see, grab the wiring tool and wire this signal to the false case, and I think that'll do it. Let's think this through here. We want, this is going to be true until the count drops to 0, and then it'll be false, and we'll execute the false case on that occurrence. The true case can be left empty. And so let's go back to the front. Let's go back to the front panel. We'll run it from there and see if we get the kind of behavior we want. I'm going to hit Control S here to save everything. Use the operate tool to bring the initial time up to, say, 12 seconds. Hit the run button. No rooster crowing yet. Keep our fingers crossed when we get to 0. 2, 1, 0. There we go. The basic function of our kitchen timer realized virtually on our laptop. Maybe I'll add, it's not altogether trivial that with a virtual kitchen timer you are free to select whatever sound you want to play. All you have to do is find a sound file. That's clearly an advantage of a virtual instrument. With a physical kitchen timer, you got to pull off the back and replace the bell, and good luck finding a bell that'll play a chicken or a rooster crowing. Let's see. One last thing I think I'll show you before we quit, a debugging feature that is quite handy. Back to our block diagram, up in the tools palette of the block diagram, let me go back to the front panel a minute and select for the initial time, say 12 seconds again. If I go back to the block diagram, I just want to show you this one debugging tool and then we're done. Under the tools, the tool icons here, we know about the run button. The other one I want to bring to your attention is this little light bulb. Says highlight execution if I hover over it. If I run this thing with execution highlighted, LabVIEW gives me a nice display of how the signals are varying on the block diagram. And let me just highlight that tool. Now you see it's kind of, again, LabVIEW is very visual. You sort of see an orange colored light bulb glowing there. And now if I hit the run button, you'll see some of these signal values change. So here you see we started at 12. This is now 12. This is true. This is now 11. The case is false. Sorry, the case is at true, so nothing's happening in the case structure. But you can watch the signal values count down. And we'll watch a few seconds longer until it actually gets down to 0, and you'll see the false case comes up and the rooster crows. So this has been my introduction to LabVIEW. I hope you found it useful. I've tried to highlight some of the features and idiosyncrasies that I found to be helpful getting started. It's one of these things that you really have to get in there and muck around and learn some things on your own. You won't get much out of it just watching me do it, but hopefully a little of the fear factor perhaps is lessened, and you'll have better luck with it. So just a couple more seconds, we should see the false case come up and the rooster crow, and that'll be our signal that our day is done. 3, 2, and by the way, this is not necessarily in real time. Things tend to be slowed down here when you're doing this highlight execution mode. Okay, we're down to 1 inside the while loop, and I think next iteration we'll go to false, and we should hear the rooster crow. Go. So that's it. I hope this was useful, and thank you for your attention.